Hi everyone, and welcome to our video on solving exponential equations using the same base. Okay, so on these problems, what we want to do is try to write the left side and the right side to have the same exact base. So for this first one, we want 2 to the x equals 2, I'm just putting it in parentheses, to something. Okay, so I'm just using those kind of space holders. Okay, so the way that we can do this is we want to pick apart this 1/8, and we want to say, well, 8, so here's to the side. We can use prime factors, so you just want to think what times what is 8. Well, 4 times 2 is 8, and then once you have a prime, you could circle it, and then 4, well, 4 would be 2 times 2. Okay, so what this is saying is 8 is the same as 2 cubed. So that means, let me move that down. So sorry if you're using pen. So let me give myself a little bit more space. Okay, so what we currently have is this 8 is the same thing as 2 cubed. Okay, so we're getting close. We have 2 and 2 are similar, but I need it to not be in a denominator like this. Well, there's all sorts of rules for exponents. The rule that we'll use here is that if you have 1 over some base to a power like this, you can change it to base to the negative power. Okay, so we have this rule that can help us. Okay, so this right side then becomes 2 to the negative 3. So it's 2 to the x equals 2 to the negative 3. And then that way we do see it. Okay, so we've got that 2 and that 2 are the same. Oops, on my rewrite, I forgot x. There we go. So those 2 are the same. And then that means this negative 3 must equal x. So that's our answer. So x is negative 3. Okay, so that's done. All right, number 2, I want to also rewrite it so it has the same base. Okay, so let's not even write it yet. Let's just go do our prime factoring to the side. So 625 ends in 5, so that means 5 will go into it. And if we need a calculator, that's fine, but 5 will go into 625 125 times. And then 5 is prime, so I'm circling it. 125 is ending in 5 also, so that means 5 would go into it, and it would go into it 25 times. So 5 times 25 is 125. 5 is prime, so I'm circling it. And then 25 is 5 times 5. And so what we currently have is 5 times 5 times 5 times 5. That is the same as 5 to the 4th. So what we're currently saying is 5 to the 4 is 625. So that means this here I can change to be 5 to the 4. Okay, and then now it's matching right away where I have my bases ready. So that means these powers must be equal. So that means x plus 6 is 4. And in this, we solved like a normal equation. So all I have to do is subtract 6. And we would get x is negative 2. Okay, so that's how we can solve these ones by hand. Let's check out these other expressions. Okay, so the main deal is trying to get them as the same base. Now, one thing that's important about these two, let me highlight it, is the part that had the exponential x value thing on it, the exponent was a variable, was that these bases were already prime. So prime number is something that can only be divided by itself in 1. So that's how we usually want to write these if they're not prime. So over here, they both have x involved in their exponent. And then we look at them and we would recognize that 9 is not prime. We need to make this into something that is prime by using our prime factoring that we did on how we did on the previous problems. Okay, so for instance, 9 is 3 times 3. So 9 is the same thing as 3 squared. Okay, so this in the purple is 3 squared, and I still keep those parentheses, and then it's raised to the negative 2x. And then the right side, well, I have 27 to the 3rd. Well, that's all good. What I want, though, let's just pick apart just the 27. Okay, so 27. I'm thinking, okay, so 3 times 9 would be 27. And then 9 is 3 times 3. So currently that means 27 is the same as 3 cubed. Okay, so this 27 is 3 cubed. And then it's also cubed. And then there's another parenthesis, and then there's a 2 plus x. Okay, so that's what that one looks like. All right, either way, what we currently have is the bases are equal to each other. So I'm gonna highlight just the base, so just the 3 and just the 3, which means their powers, let's highlight those in pink, would be equal to each other. Okay, so as soon as we get the bases being the same, then the powers would equal to each other. Okay, and what these parentheses do here are going to change it into a multiplication. So it acts kind of like regular multiplication. So like right here, let me just put that. So it would be 2 times negative 2x equals, and then right here, 3 times 3 times 2 plus x is also all in parentheses, just like that. So these powers become a multiplication, become a product once it's rewritten. And then now we can simplify. So on the left, it would be negative 4x. 2 times negative 2 is negative 4. On the right, let's do it in 2 steps. 3 times 3 is 9. And then now we could distribute. So I have negative 4x is 18 plus 9x. Okay, so this is what this looks like. And then from here, I'm still trying to solve for just x. So I would subtract 9x to both sides. And that would give us negative 13x equals 18. And then now we could divide by that negative 13 to get our final answer. Okay, so x will equal negative 18 over 13 as a fraction. We could change it to a decimal if we want to, but I'm going to leave it as a fraction. Okay, so that's how that one breaks down. Okay, so it's changing that base. Really, the first step is prime factorization, and then eventually it becomes just a regular old linear equation most of the time. Okay, so that's how these ones break down. Okay, let's see number 4 here, where we have, so here's what's good about the base e, is that we already have our e is the base. So that's already ready to go, which means these powers would be equal to each other. Okay, so we have 2 minus 8x will equal, it's 4 times, okay, so the parenthesis is 4 times 3x minus 1. And so now I can distribute the 4. So we'd have 2 minus 8x equals 12x minus 4. And then I'm still just solving this linear equation at this point. So I'm going to subtract the 12x on over. And at the same step, I'm going to minus that 2 on over. Okay, so 2 minus 2 is 0. And then I'd be left with negative 20x equals 12x minus 12x is 0 equals negative 6. And then my final step will be to divide by negative 20. And after that, 2 negatives over here is positive. 6 over 20 would reduce to be 3 over 10. Okay, so that's it. Okay, so the other way that you could do these problems, okay, so I like to do it by hand. I think it's a little faster if we catch on to it. The other way we could do this, so we could do this using a calculator. So let me just rewrite. Let's check this one. Okay, so it looked like this before I did anything to it. What we can do is we could graph. Okay, so here's, I'm just putting a squiggle. We could graph y equals this left side, e equals e to the 2 minus 8x. And we could also graph the right side, e to the 4, 3x minus 1. So we could graph these two. Okay, so let me go to my Desmos again. Okay, so and that's how we could do all of these problems if we wanted to check. Okay, so here's my graphing calculator. Okay, and I'm just going to plot those in. Okay, so I have y equals e to the, and then parentheses might be needed anyway, so I'm going to do 2 minus 8x in parentheses. and then we'll have our another graph, e, well, this one's in parentheses actually, e to the 4, parenthesis, and then we'll raise it to 3x, so we even put that in parentheses, 3x minus 1. Okay, so there we go. Okay, so there's the 2. And then what we're looking for is where they intersect each other. Okay, so where they intersect, and it grays it out for us. And we're looking for our x-coordinate, because that's what we're solving for here, x. And notice it's 0.3, which is the same as 3 over 10. Okay, so this is the other way to do it. We can graph them and just find the intersection. Okay, so, and just to check one other, like for instance, if we were to check number 2. Okay, so let me quickly graph those ones. So 5 to the x plus 6. And then let me graph that. So the second side is just 625. Okay, so that. Okay, notice it's only showing the red. Here's where it wants y equals. Y equals 625. Okay, and notice I can't see anything still. Well, because this is the y coordinate, 625. All right, so that means I need to go way up high. There we go. And then now I can zoom back in. And let's click on it, and we can see, there it is. -2 was the x value that we wanted, and that was what we found when solving it. Okay, so that's the other way to do this, and Desmos is very fast. A handheld calculator, though, it takes a little longer time to type in. All right, so, but either way, there's 2 ways to solve these, so if you're taking a test, definitely check both. All right, but that's that. So that's how we solve these equations. If you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.